In this unit, we're going to use Redis and Python to build a simple rate limiter. A rate limiter keeps track of how many requests a user is making and prevents careless users and malicious actors from making too many requests. This is especially important when an API exposes expensive operations. If you're hosting an API that does image processing, for example, you want to make sure that users don't overwhelm your servers. A rate limiter can prevent this. There are many ways to build a rate limiter. Two common techniques are the fixed window and the sliding window. A fixed window rate limiter counts all requests within a specific time interval. So as its name implies, you can stipulate that a user not make more than 5 requests in any 1-minute fixed interval. Here, each tick mark represents a request. So within the 12:01 interval, the user can make up to 5 requests. And within the 12:02 interval, the user can make another 5 requests. In both cases, the user will be rate limiting on the 6th request within the fixed 1-minute bucket. With a sliding window rate limiter, you can specify that a user can't make more than 5 requests in any given 60-second interval, regardless of minute boundaries. So perhaps the user makes 3 requests at 12 o'clock and 30 seconds, and 3 more requests at 12:01 and 15 seconds. In that case, the user will be rate limited, even though their 6 requests cross the minute boundary. A fixed window rate limiter is a bit easier to implement, but less precise. A sliding window rate limiter is more precise, but trickier to implement, uses a bit more space, and is slightly less time efficient. In this unit, we'll see how to implement the fixed window rate limiter, and in the upcoming challenge, you'll build your own sliding window rate limiter. In Redis Solr/DAO/base.py, we've defined the rate limiting ABC. It consists of a single method called hit, which takes a string. This string uniquely identifies the thing being rate limited, so you'll likely pass in a user ID or an API token here, which indicates which user is hitting the service. If the user exceeds the rate limit, the method will raise rate limit exceeded exception. Now let's open up the fixed window rate limiter implementation. It's in the file redisolr/dao/redis/fixedratelimiter.py. You can see here that the initializer takes a minute interval, and the maximum number of hits allowed in that interval. If we turn to the implementation of the hit method, you'll see that we first get the name of the key storing the number of hits. This key naming is important. The schema for a key looks like this. We have the text limiter, followed by the name of the rate limiter, which will usually contain the user ID or access token I just mentioned. And that's followed by the minute block, which is the minute of the day or the block of minutes in the day that constitutes the fixed window. Finally, this is followed by the max number of hits for that interval. So, here we create a pipeline. Then we atomically increment the value at the rate limiting key by 1 using the incr method. We set a time to live on the key with the expire method since we don't need the key once its interval is complete. We call pipeline.execute to send the commands. Then we check to see if the number of hits is greater than max hits. And if it is, we raise rate limit exceeded exception. So we just saw how to build a fixed window rate limiter using Python and Redis. There are quite a few advantages to this rate limiter. It's space efficient, consisting of a counter stored in a single Redis key. It runs in constant time, employing 2 ov1 commands, incr and expire. And it uses a pipeline, ensuring only 1 round trip to Redis. This design will work for a lot of use cases. However, if you need more precision, you'll want a sliding window-based rate limiter. And in the next challenge, you get the chance to build one.